Welcome to Homework Lib.
We're going to answer the following question. We're going to have a plane that is flying 25 degrees north of west. So remember that we're going to have the following situation. North of west at an angle of 25 degrees at 190 kilometers per hour. On this point, we're going to find a wind that is going to be going 15 degrees north of east with a magnitude of 45 kilometers per hour. So over here we want to know what is going to be the plane's new velocity with respect to the ground in the standard position. So in this case what we need to do is to add the velocity of the plane as a vector plus the velocity of the wind as a vector, both of them. So first of all, the velocity of the plane is going to be divided in velocity and x. Same thing with the velocity of the wind. And the sum of them are going to be the total velocity on x. So the projection of the plane on the x-axis is going to be equal to 190 kilometers per hour times cosine of 25 degrees plus, and in this case it is going to be negative since it is pointing towards the left on our coordinate axis system. And we're going to have as positive the velocity of the wind on x, which is 45 kilometers per hour, times the cosine of 15 degrees. Similarly, the velocity on y is going to be equal to plus 190 kilometers per hour sine of 25 degrees plus 45 cosine sine of 15 degrees. So the velocities on each of the components are going to be, for the first one, on the x contribution, we're going to get minus 128.732 kilometers per hour. And on the y axis, we're going to get 91.944 kilometers per hour. So what we know is that according to the positions, the final vector over here is going to be pointing on this direction, and we're going to have that the final velocity would have the component bx and the component by, which is going to be the same as the component over here, b on y. Okay, so the total magnitude of the velocity as a magnitude would be the square root of bx squared plus by squared. This is just applying Pythagoras theorem. So the result would be 158.195 kilometers per hour. And to know the direction, what we're going to do is take the angle theta as reference. So since theta is going to appear there, the tangent of theta is going to be the opposite catet, velocity on y, divided by the adjacent catet, velocity on x. Of course, in both cases, we're going to have the magnitude of the vectors. So from here, theta is going to be equal to our tangent of 128.732, of 91.944 0.944 divided by 128.732. So the angle theta is then 35.535 degrees. So in this case, if we round up everything to 3 significant digits, or to 4 in the case of the velocity, what we're going to get is that the net velocity of the plane with respect to the ground standard position is going to be of 158.2 kilometers per hour I'm going to keep only one digit after the decimal point, at 35.5 degrees north of east. Sorry, north of west, of west. And with that, it would be all. Thank you very much and have a good one.